Hello everyone and welcome to today's SANS webcast, SIEM Design and Architecture. My name is Carol Auth of the SANS Institute and I will be moderating today's webcast. Today's featured speakers are Justin Henderson and John Hubbard. Both are SANS instructors and course authors. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to John.
Hello everyone, welcome. We're thankful you could all take time out of your day today to join us here. This is the first of a three-part webcast series. Today we're going to be talking SIEM Design and Architecture. This first webinar is inspired by SEC 555, which is Justin's new class. We've had a lot of people asking for more background on the SIEM space and how to build their own. And so today we're going to bring you that in slides, followed by a demo from Justin, who's ready to put the whole thing together for you in real time. The second webcast will be Detecting Modern PowerShell Attacks with SIEM, where Justin's going to show how to use what we're building today to find some extremely difficult PowerShell-based post-exploitation maneuvers, and then followed by a third webcast in November on modern log parsing with enrichment. That's going to continue to show you the power of what we're doing today, and we'd like to show some of the features that we like with the particular system we set up today and where we'd like to see the industry go in that third webcast. So first, some intros. We've got Justin. He's the instructor for several classes and also author of the new hit course SEC 555, which is SIEM with Tactical Analytics. This is a class that's only run 2 times, but it's already been a smash hit. There's a waiting list for spots in some of the locations already. It's been a real success. I had the fortunate chance to sit in on the beta, and we've had some outstanding comments from students, and it's one of the reasons we're trying to bring more of this content to the community today. My name is John Hubbard, and I'm currently a SOC lead in the pharmaceutical industry and also an instructor currently for 511 and soon to begin teaching 555 myself in the next few months. Justin and I teamed up on this. We've been working together because we share a common goal. We're both passionate blue teamers, and between the two of us, we're on a mission to show people how awesome and exciting defense can be. We've seen the energy and the enthusiasm from the students in the SEC 555 class, and it's really opened our eyes to the amount of hunger for the knowledge around the SIEM space and the things that can be done in that area. So that's what we're hoping to bring you today with this webcast and continue to bring you over the next few months with parts 2 and 3, as well as with maybe some other surprises in the not too distant future. So with that being said, let's get into today's content. So today we're going to be talking about SIEM Design and Architecture, and we're going to jump right in here with the Elastic Stack. The Elastic Stack is a good representative architecture for pretty much any SIEM. There's logs that are going to be generated on edge devices at some source, and they're going to be going towards some sort of aggregation. Now in this particular scenario, that aggregator is going to be Logstash, and they can be aggregated either globally or locally. They're going to get funneled into the system, and after this, in this case, we're going to be feeding those to the Elasticsearch engine for storage and search and indexing. Elasticsearch itself is a RESTful text-based search engine based on Apache Lucene. It's a standalone product, but it is a full, complete product on its own that can kind of act as a wrapper for Apache Lucene, and it adds the REST API and a bunch of other convenient features that go along with it and make it very convenient to use. The third piece of this is going to be Kibana, and Kibana is the GUI front end that makes it easy to interact with Elasticsearch. What it does is the visualization, searching, some of the new cluster management features that are coming out in the newest version, as well as monitoring for the health of the stack, some machine learning and other visualization tools come from there. Most SIEMs look something like this. Logs are going to be moving from the various sources out on the edge, and they're going to get funneled to a local or a global aggregator of some sort that's going to parse them and get them ready for storage and indexing. Then there's the interface that's going to allow searching, setup, management, and in this particular scenario, that's going to be Kibana. So we're talking Elastic specifically today because it's a great free open source solution that pretty much anyone can experiment with rather easily, and Justin's going to demo that at the end of this webcast. It also makes a great SIEM and is heavily utilized for the SEC 555 class, and we've seen a lot of interest in it. So how do these logs on the edge get sent in? Of course, you can use the typical things for Linux, syslog, and some of the other built-in mechanisms, but Elastic also has their own set of log agents, which they call beats. There are separate beats for each type of data you want to collect in this scenario. Some of the most important ones for security are going to be WinLog beat, which is going to allow you to collect Windows logs, packet beat, which can read network data, file beat can pick up log files and tail them off across the network. You can also build your own beats, and some of these already exist, like unified beat, which can pick up the snort unified to format and send those in. There's flow beat for SFlow collection, ping beat, and the goal of these is to really just reduce the network traffic through filtering and coalescing on that edge device. So you're only sending in those high-value logs that you're truly interested in, and you're doing that in a convenient and efficient way. Another setup that it's worth noting is that you don't actually have to send beats agents collected logs directly to Logstash. You can actually send them directly to Elasticsearch for an extremely simple setup if that's the kind of use case you want to get into. This is generally the same for any of the other type of SIEMs. We have a log agent, and logs are either pushed by their native agent or some other solution and collected by log collectors of some sort. Ideally, these solutions are going to make it easy and robust and secure to collect your logs. For beats, filtering is one of the great strengths for that. It does a great job of doing that, and a lot of other solutions can do that sort of thing too. Some SIEM solutions want to collect everything on the endpoint with the idea of making sure you have it in case you need it someday. Justin and I kind of prefer filtering things as far up the chain as can be done, so you keep things efficient and running smoothly. One of the other core components you've probably heard of for the Elastic Stack is called XPack. XPack is a key piece for enabling enterprise-grade security. It's one option for doing that. There's 3 different levels for using XPack. There is the basic level, which enables monitoring for your stack health and a few other basic features, and then we have the gold level, where it starts to be commercial support for your Elastic Stack cluster, and that throws in the security, role-based access, encryption, and things like that, as well as alerting and reporting for specific conditions that you're interested in. Platinum is the high level, and that includes graph making, visualizations, as well as the machine learning functions that also come with that. So perhaps you aren't interested in the Elastic-specific solutions from XPack, or maybe you have some other solutions for agents already deployed from other solutions. That's okay. You can still use those things with Elastic Stack a lot of the time. We did want to point out that there are other alternative setups available. For agents, NXLog is one of our favorite. It's very robust. It's priced rather low. It has some outstanding features, and it's very compatible with many, many different types of operating systems and log sources. XPack, in terms of the security features, there are packages called read-only rest, as well as another one called SearchGuard, which they themselves are free for basic securing of your Elastic Stack, as well as offer their own commercial versions of support for some of the more advanced features. There's also the supporting tools that come for the Elastic Stack. Sometimes you might want to do something like load balancing, and there are free tools for that. HA Proxy is one great one. It's a very easy solution to set up that can be deployed for your log sources that need that kind of thing. And we'll get into that in a minute. And for message brokers, Redis, RabbitMQ, Kafka, all of them easily integrate with Logstash. They have input filters that can be used to integrate directly with those particular message brokers, and it makes it very easy. There's a lot of use cases for bringing in separate brokers into the system. A lot of them involve if you want to do maybe geographically dispersed clusters of various types and things that are more complicated like that. We're not going to really get into that too far today, because that's some more of the edge cases for very, very big deployments, but Elastic themselves does have documentation on that if you're interested in that. So onto Logstash. How does it work? At the highest level, it's these 4 input blocks. These 4 blocks. So there's the input block, which is first. That's going to bring all of the logs in the various formats that you are sending them to Logstash in. There's a optional queuing block that can be used. It can be disk or memory persistent queuing, and then we have a filter block, and this is where all the special stuff happens, and we're going to be going a little bit deeper on this particular block. This is where you do all of the parsing of the logs that came in on the input and came out of your queue. And then after they are parsed and enriched and whatever you need to be done with them, they hit the output block, which can send them to various different destinations. And that is very, very flexible. There's a lot of outputs beside Elastic that can be sent to. So what do these 3 stages look like in the actual setup? Here is a very, very basic Logstash configuration file on the right here. The input block, which you see on the top there, is how you collect logs. And in this particular scenario, we've got 2 inputs defined. We've got one for syslog, and we're listing that it's going to be coming in syslog format on port 514, as you would expect. And then we also have the beats input defined with port 5044. There's a lot of options here. You can use anything from Twitter to IRC databases, raw TCP, UDP packets, whatever you want. The input is very, very flexible. It allows you to take in just about anything. The filter block, which is not filled in this case because it can get very complicated in this section depending on how you want to parse and enrich things, allows you to modify and enrich your logs. We're going to get into this later, but this is where the logs are ultimately parsed into the fields and broken down into a JSON structure, which is what's going to be ultimately sent into Elasticsearch at the end. In the output block, this section is going to let you set the output options, and not just for Elasticsearch, but for anywhere else you want to send it. You can have output go to Amazon SNS if you want to get text messages directly from Logstash. You can send it to other message queues. You can have it send emails, output files, really whatever you'd like there. There's a lot of flexibility. Sorry. All right, Kibana. Kibana is the GUI front end to Elasticsearch. Elasticsearch is fully functional on its own, as I said, but it is interfaced with via REST API, and Kibana makes doing that easy and convenient for your analysts who are going to be using it. So there's the 3 main functions that we often use for Sec 555 as well as an analyst would probably be the 3 top tabs you see on the left there: Discover, Visualize, and Dashboard. This is the dashboard function. Discover is where you do your searching of your logs. You may visualize them in the visualization section, and you save those visualizations, and you can turn them into gorgeous looking dashboards like this. You can bucket the data in various nested ways and derive a lot of patterns out of the data that you may have not seen otherwise. So in this case, this is a lot of Apache log data. It looks like they were using in the upper right corner, for example, traffic that was coming from various countries and then breaking it down by the response codes that were coming back from the traffic from those countries. There's a tag cloud in the bottom right. There's also some swim lane graphs in there, a count of unique visitors from those countries. And then on the bottom, you can't really see it because it's cut off, but it is a GeoIP map of where the visitors to a particular website is coming from. And this is just a demonstration picture off the Kibana website. But that's done with a GeoIP filter block that is put in there, and it's very easy to integrate. So those are the main 3 sections of Elastic Stack. When it comes to clustering things together and building an actual SIEM, one of the things we're all probably focused on is speed. How many of us have a slow SIEM out there? Probably quite a few. The good news is about the Elastic Stack is it scales horizontally quite well. If you need more space or performance, you can add more nodes to your cluster. And by cluster, I mean a cluster is a group of nodes running the Elasticsearch program. So that could be various node types. So each node could either be a master eligible node, data node, or some of these other 2 nodes that are less common. But master and data are the 2 most important. All clusters have one and only one master node. And in big production deployments, typically you would make a dedicated pool of nodes that could be the master node, and you wouldn't share that with the data node function because you wouldn't want to impede their ability to be the master node in case they were called upon to do that. Data nodes is where the data is actually held. It's held in what's called indexes, and indexes very typically will be 1 per day for each type of log. For example, all of today's firewall logs might be in 1 index. That index will be broken up into multiple pieces called shards, and the shards will be distributed across all of the nodes in an efficient way to try to optimize the speed for your search. Shards themselves can be primary or replica shards, which I've tried to show there on the chart on the right with the P and the R in the boxes. This is very simplified beyond what is actually going on, but I just wanted to draw attention to that particular fact. And along with primary nodes, you can have multiple replica nodes. And the more replica nodes you have, the more copies you have of the same data, and therefore search will go faster. And therefore, when you add more data nodes to a cluster, your speed will get faster as it can search all of those things faster and in parallel. In addition, with that, there's also hot nodes and warm nodes. Hot nodes are the data that you would usually keep on SSD storage and want to access very quickly, whereas warm might be the spinning disk nodes for older or less frequently used data. So scaling Logstash, Elasticsearch is pretty easy, but what if you need more log input capacity? Elasticsearch isn't really worried itself about log volume or events per second or log source numbers. You just need to have the hardware to handle that. And Logstash can also scale up and down in the same way. If you have the hardware to add, you can throw at it and usually utilize it. The way Logstash works, however, it doesn't have any inbuilt clustering. You just actually add more Logstash nodes in parallel that are going to be doing the exact same thing. So you simply put up another Logstash server with the identical configuration in that server and make sure all the logs that are going to it are distributed evenly. So in this case, if you have a Beats agent installed on someone's laptop, you can give a list to that Beats agent of all the live Logstash servers, and it will try to contact them and use them in a load balancing type way. And if it sees one goes out, it can stop talking to that one and distribute the things like that. Also, if you have log sources that are not aware of doing this, you can use the load balancer to make sure your logs are sent in a distributed way that will allow you to ingest everything safely and not drop anything. So now that we've talked about all the pieces here, let's talk about the full pipeline here. This is the 50,000-foot view. So we're going to have on our edge devices either Beats or some other kind of agent. We're going to have other types of log sources that are collected, NetFlow, syslog, anything else that might be going to a load balancer, and that is going to be going to a cluster of Logstash servers. Those Logstash nodes are going to be then collecting those on the inputs. They're going to be queuing them so that nothing is overloaded, and the filter block is going to be picking stuff out of the queue as it can, and then it's going to be putting it to the output block, which will ultimately send it to Elasticsearch, where it is indexed and stored and kept there for search and interaction with Kibana or anything else. So this is the basic log pipeline, how it would look in any typical simple setup. Perhaps you have a situation where you have the inability to install agents on your endpoints, or perhaps you have a very slow, poor connection. It's finicky, you can't install agents on the systems, maybe it's lab equipment and you're just not allowed to. There are other ways to get around that with this. You can use something like the built-in Windows event forwarding system, and you could take something like NXLog, for example, and collect logs with the built-in Windows log forwarding, Windows event forwarding system. From there you can batch and compress them as needed and send them over a low bandwidth link in as big of a bundle as you'd like to Logstash. And as long as you're okay with the delay of bundling it, you can compress more and more logs into a batch and get higher and higher efficiency numbers. Alternatively, Beats agents also have options for setting compression and batching and those sort of things. Bandwidth itself is not something that should stand in your way of setting up a system like this. Especially with Elastic, there's a lot of great options for endpoint filtering and compression. Another common architecture we see a lot is the cloud log pipeline. So what about your cloud services? There's kind of two types. There's the cloud services like Gmail and software as a service type of stuff. Versus your infrastructure as a service, VPSs and things like that. If you have cloud services where you don't control the operating system, the good news is Logstash can already natively speak to a lot of those services with the built-in inputs that come from Elastic. In other cases, there's generic HTTP REST request inputs that can be used to speak it to any of the APIs and pull those logs out. In other cases, you might need to use scripts to pull the logs actively yourself and then maybe have FileBeat pick them up and send them the rest of the way from some edge server. If you have cloud servers that you have full control over, like any VPS, AWS type system or whatever it is, you can just collect logs in the same way you would for any on-premise equipment and make sure the logs can be collected in a safe way coming into your environment from the internet. So now that we've talked about some of the high-level architectures, let's get into some of the crazier stuff here. You might have the interesting problem that your SIEM is required to collect anything and everything under the sun. As we all know, this bogs down performance because there's more indexing going on, there's more things to search all the time. It makes actionable content as an analyst more difficult and slower to find, especially for the new people. So one of the things that Justin and I have put forward is the idea of the tactical SIEM. And what you would do there is have a special SIEM just for your hunt team and your SOC, your blue team members with only actionable high-value logs, and do it in a very cheap and efficient way that can perform very quickly and get you the answers you need fast. You can insert Logstash into the path of the logs that are already coming into your current SIEM and split the data out, or you could have your current SIEM pass on those logs further for directly to Logstash and have that filter them, enrich them further, or do other things, and then have only that stashed into the tactical SIEM, as we call it. This is a setup we've seen with multiple companies, and they've had success with it. So speaking of enrichment, perhaps you're unhappy with the parsing or enrichment capabilities of your current solution. Well, this can also help with that. Imagine this kind of scenario. You want to get some additional logs put into your syslog that is not available from the source. Perhaps you have an asset database or something you want to just enhance the logs with. You could insert Logstash in your log path to your commercial SIEM that you have currently and just do that additional enrichment and then continue to pass it on. As long as your SIEM can handle the format that it's coming in with and parse it, that should be no problem. So you can actually add new features to your current SIEM if you don't want to invest in any of these other things. What else can we do in terms of enrichment? So enrichment is a pretty interesting topic, and in Sec 555, Justin goes pretty deep into this. We're only going to touch on it a little bit today, but I wanted to give those who are new to this system an idea of what kind of things that can be done with it. So this is a very, very simple example. This is the TLD filter. It's one line. You point it at the line that has a FQDN on it, and it allows you to break DNS host names down into various sections that can be individually queried, and that can come in a lot of use for analysts or threat hunters. You can ask questions like, what com, edu, gov, org, net addresses are we going to? Perhaps you're a US-based company, so you can assume that maybe other countries' TLDs are more questionable than your own, or maybe you know a specific set of websites that your analysts can look out for. This can help you do that, and it won't have to be done at search time because this will be pre-indexed with all of these fields broken out like this, so it's extra fast to do it like that. Here's another example, user agent filters. User agents can be done in the same way. There's a user agent filter block. You can throw it in and point it at the user agent that's coming in, and it will break this down into various sections. So you can see here we got Windows Vista IE7 used on the top. That will break it down into the OS, the major and minor versions, the name of the browser, the OS name, and perhaps if there was a device that it could discern, that could be thrown in there too. This could help you make a dashboard for maybe who's using old or out-of-date browser versions in your company, what operating systems you have on your network, and you could alert on rogue devices, things like that. You can obviously do this with a lot of current SIEMs too, but this helps break up that data before it gets indexed, and it makes it very, very easy to deal with because each thing is going to have its own field, and it keeps the data nice and clean. Here's a more advanced example, and this is something that Justin gets into in 555. Entropy. Mark Baggett has wrote a Python-based server application called freak.py, and it is something that's really interesting. It can take a body of text and look at the statistics of word and letter breakdown, and then you can, it will learn from that, and then you can feed it a piece of text, and it will tell you how well what you've given it matches that corpus that you've trained it on. So what Justin has suggested in 555 is taking the Cisco umbrella top 1 million domains to train it, and then use the domain names that you actually see for people's web traffic and rank those against that. And it helps point out randomized looking domains rather effectively. So that's the block that it uses to make the REST call inside the Logstash config. It's pretty easy. And then it puts in that freak field on the top there. So we see for Google it's 28, and for Microsoft it's 20. The idea with this is the lower the number, the more odd that that particular string is, and we'll see that come back in a second. Here's another one. Can your SIEM currently tell you how old a domain is on the fly as it sees it? With this particular script that can be used as a filter enrichment in Logstash, you can give a SIEM this power. So the idea here is this is a script that will do a whois lookup and can give you arbitrary data out of that whois. So you can check the domains you're going to against a list of the top 100,000, 1 million domains, whatever you're interested in, with the idea that if your employees are going to a non-ranked website, that's one indicator that it's more likely to be malicious. Obviously, it's not going to be probably perfect on its own right, but when you combine it with some of these other things, it's going to get even better. At the same time, you can also have it check the creation date, and the creation date is a very, very powerful thing to actually be able to include in your logs. That is very, very interesting and great at picking out exploit kits and other malicious domains, because they tend to be created on the day that they're going to be used for evil. So here's a little demonstration of that. We want to bring it home with a demo of what the problem is here. So this is a list of domains that I put together. These are top 10,000 domains mixed in with recently malicious websites. And I would venture to guess most people would not be able to pick out which is which from this list, especially if you're a newer analyst, maybe looking at IDS alerts. Without any enrichment, looking at these, they all kind of look a little random. They look a little odd with the words. You can't really see exactly if they're bad or not. And if you can't tell, your SIEM definitely is probably not going to be able to tell either, unless you're giving it a threat intel feed that it already knows about. So I took some of these out of exploit kit domains for the day, and I fed them into those various enrichments I talked about previously. And here's what we got for the exploit kit domains. So the frequency score was rather high, and the reason for that is because I only had it doing the top level boxplea.com and salehat.com. I didn't have it doing the subdomain, which is random, because there's a lot of subdomains with randomness that could throw off. So I didn't do it for this example, but you can see the rank is 0 and the creation date was 8/3, which was the day I did this. So with those two pieces of information, that's enough to maybe start floating these domains to the top and start investigating what happened when you talk to these things. What about with WannaCry? Now, WannaCry is something I'm sure we're all familiar with. When you feed the WannaCry domain into this, you get a frequency score of 5.12, and as of August, when you fed it in, you actually got a rank number back, because apparently we're all obsessed with going to the WannaCry domain, and to the point it is now the 128,000th most popular website on Earth. But the creation date would have triggered because that was created the day of, obviously, by Marcus, as we all know that story. And so that would have been another way to float this domain to the top on the day of that this attack was going on. It was a super random domain, created that day, no rank, 3 votes against it. If you were to be able to combine that with threat intel, there's a lot of things that would not be able to slip by just these very basic checks alone. So let's go back to this list. If you were able to tell which ones are which, I'm very impressed. But what I did here to create this list is I went to Malware Traffic Analysis, which is a great website for exercises, and I pulled some malicious traffic from the day, as well as the WannaCry domain and some other stuff, and I put them together, and if you couldn't tell, it's actually the entire left side is the bad domains, and the entire right side are good domains. It's hard for humans to spot this, and that shows why some of this enrichment is extremely, extremely important for your analyst to have, because just looking at this, it's very unlikely you would be able to tell all of this is exactly what it is. So I took this and I did another experiment to see how well it would perform at catching this entire thing. I took 24 hours of my home DNS traffic, and note this is only DNS traffic. There was no HTTP or anything else, purely working on the FQDN, and I fed those bad domains into my DNS traffic at home. And I put that in, and I did those enrichments to it. And so what we have here is the input on the left. Those are the bad domains. And on the right side, I used Kibana to make myself a dashboard that is just any domain that was unranked and was created anytime in 2017. And what we have here is almost a perfect match for malicious domains being showing up here on the right side. The only things where it failed was the WannaCry domain because, as I said, it's now ranked. And there was one domain that was a false positive. It was something that was associated with a Radiolab podcast that I had listened to that day, and so they had just created that website. But nearly perfect detection of the malicious domains, which I was actually pretty impressed by, and thought for not planning this out at all, it was a very, very impressive result. So what we have here is 1,000 domains that I had input from my home. 10 were bad, and of those we had 9 true positives. We had 1 false positive, which is 0.1% of input. And remember, that is using basic enrichment based on domain names only. This wasn't looking at anything about the HTTP traffic or kind of traffic. This is purely the domain name. I think that's really, really impressive. 1 false negative too that would not have been on the day that it most mattered. So that's pretty outstanding results, I would say, for just these basic enrichments. And this is where Sec 555 will continue on and show you a lot of these other techniques that can be done with a SIEM that's set up to do these kind of things. There's a lot of outstanding ways that you can catch malicious traffic in your environment if you were to have some of these capabilities in your SIEM. And remember, what we've shown you today, this was all basic enrichments. You can add this to your current SIEM by using Logstash, inserting it in the path, or doing a tactical SIEM. And these are all free tools that scale horizontally. So that's my slides for now. I'm going to pass it on to Justin for a demo to show you just how easy setting this kind of thing up can be. So Justin, over to you.
All right, thanks, John. That was awesome. But now on to the cooler stuff, which is my part, demo time. So for this, all I have are some pre-built Ubuntu 16.04 systems. They are set up, and I'm going to show you how easy it is to stand up a multi-node Elasticsearch SIEM, hopefully as fast as I can. I know some of this is kind of hard to see. Let me see if I can go in this way. I don't know if I set this up, but yeah, okay. So I'm going to run through these and try to do these as fast as I can. This is kind of like my speed run of setting these up. So on these systems, all I have is 2 files downloaded. The install file for each component, whether that's Elasticsearch, Logstash, or Kibana, and the free copy of, free trial of XPack to get all the features. So I'm going to run through here and just very fast install these. So Elasticsearch, we are simply installing the Elasticsearch package. Nope. There we go. Then I can do an offline install of XPack, which is this. And I've got all these in a file I'll share with you guys later because I know this is a little bit hard to see. So here we've got Elasticsearch is now fully installed on this box. The only thing you need to do is do some slight configuration changes. So here I am going to give it a specific cluster name, which I'm going to call it Justin Rocks because I totally do. I'm going to give it a node name, so you'll see this later. I'll call this Elasticsearch 01. And I'm going to make it available on the network. And again, if you can't see this, don't worry. I'm going to share a text file with all the commands that I'm issuing. And because I don't want to do all in one box, I want to show you what this would look like in full scale. I am going to do a 2-node Elasticsearch setup. So there's that. And now we just start the service. So at this point, I should, if I could spell correctly, have Elasticsearch up and running on one box. So we'll test that. Give that a second to start up. It's running. I'll give that a second. I'm going to move on to the next node and keep these going. Just real quickly checking to see if that's still going. There it goes, started, boom. We'll come back to that. So I'm going to go to the next node, install Elasticsearch here. Bam. There it goes. Going to install XPack again. There we go. So again, when you do multiple Elasticsearch nodes, they all need to have the same cluster name, which in this case was Justin Rocks. I give each node its own name, which just matches the host name so that you can identify which one you're working on. I'm changing network host to 0.0.0.0 so that we can reach it over the network. And this is just to make it so that each Elasticsearch node is aware of this of the other one. So there's that. There's the second Elasticsearch node. I'm going to switch to Kibana for a second. You're going to notice this is very simple, very similar. Basically, you install the Debian package. There it goes. Before I install XPack, I'm just going to sneak up and do the configuration real quick. So again, here, I'm going to make it where we can access this over the network. So 0.0.0.0. Change the server name to reflect the host name, which in this case is Kibana 01. And I'm going to point it at one of the Elasticsearch nodes, which in this case is 192.168.2.100 for this demo. And the last step here is to install XPack again. With Kibana, this sometimes takes a while. So when I have this command issued, I'm going to switch and just get the Logstash node set up. Let that go. Here it's going. Let's see how these guys are doing real quick. Get that. Oh, I know what this is. I'm not on the let's just cheat this for a second. I was wondering why I couldn't hit this earlier, and it's because of this. If config ethos 0. There we go. So this is kind of an ugly interface, but this is just showing that we have Elasticsearch 1 up. If I check on the other one, it is also reachable. Kibana will give us the pretty interface in a second. That's still optimizing. So while that's going, I'm going to finish installing Logstash. And again, just keep in mind, we are currently at 9 minutes of my demo, and I get this isn't the most fun stuff. But if I do this right, I should have a full-fledged SIEM up in less than 15 minutes, which I feel is pretty cool. I mean, that is the power of some of this open source technology stuff. So again, same thing. I'm installing Logstash. I'm installing XPack. You don't have to have XPack. That's just what's going to let us monitor how everything is working. There it goes. I don't like waiting, so I'm going to just issue the same commands on the second Logstash node. There that is. I'm just going to edit logstash.yaml. This will just let me put the name of the node again so we can see it in Kibana. And I'm going to make sure it does show up in Kibana, and one way to force that is to add XPack monitoring enabled to true and XPack monitoring Elasticsearch URL and point it at the Elasticsearch nodes. This is just going to force it so that when we get Kibana up and running, you'll see the Logstash nodes in Kibana. You'll be able to see how much performance or how many events per second they're doing, are they running properly, all the good stuff that we really want to have. So there's that. Again, installing XPack here. Check on Kibana. Still optimizing. So at this point, I've got Elasticsearch 01 is installed, running. Elasticsearch 02 is installed and running. Logstash 01 is installed, and I just finished installing Logstash 02. Before I can start Logstash, though, I do need to give it a config file because right now, no data would be accepted. So real quick, let me add these. There we go. So the config file I'm going to use in this case, I'm going to show you real quick, is this right here. I'm going to simply have a single conf file that says accept logs on TCP port 6000. They will be JSON format and send them into Elasticsearch, which is here. So this is what I'm going to copy into each of my Logstash servers. The config needs to be identical. So the default config is etc logstash confd. I'll just call it sample.conf. Paste that in. And now I can start Logstash. There we go. Do the same thing over here. Start Logstash. And hopefully Kibana's done, which it is. Perfect timing. We'll start up. So at this point, I have 2 Logstash nodes to accept logs. I have 2 Elasticsearch nodes to store data. And I have 1 Kibana node to visualize. Let's see if Kibana is up and running. Give that a sec. Sometimes that takes just a second to load up. Come on. Shows it's listening. There it is. Just me being impatient. Default user is Elastic with a password of change me. And we should be greeted with some beautiful pictures here. Currently there is no data, but at this point we have a fully functional SIEM. So I've got Discover, Visualize Dashboard, all the fun stuff. Now, this would be a really boring demo if we basically set up Elasticsearch, the Elastic Stack with nothing in it. So I'm 14 minutes in, my last second. I'm going to show you, we're going to throw some data in here. And actually what I'm going to do is I'm going to speed test my system. I'm just on a standard laptop, and I'm going to loop and just keep sending JSON logs as fast as I can to the SIEM. You might be able to hear it. My fans on my laptop are now spinning. You can hear them kicking in. And if we go in here under monitoring, and this is slowing down because I'm using all the resources off my box. Let's see here. We've got documents starting to come in. And in a second, this should start jumping up significantly. And real quick, let's see if we can see the data. I just want to make sure the data is coming in. Nope. Nope. Data is not coming in because I just need to change this real quick. Fix that real quick. So in here, the authentication to Elasticsearch was wrong. So I'm just changing that. And should see that here in a second.
Justin, you might have typed enable when you meant enabled in one of those configs. I think that's what that was.
No! John to the rescue. This is why John is so awesome. You guys got to keep him around. So that would be the Logstash config file. Aha. You are correct, John. That one's right. Check monitoring. So here's what I'm going to do for this one. There we go. So at this point, we've got logs coming in. Go to Discover. We got 59 fields, and I can now see data coming in. And again, right in the background, I've got this sending data as fast as it possibly can from the same system to that system. So we've got 2 Elasticsearch nodes, 2 Logstash nodes, 1 Kibana, and we have monitoring set up. So you basically have your SIEM. And if we watch in here, you can see right here, this is on a laptop, and I'm at 3,000 events a second right now. And that'll keep going up to about 5,000 events per second. So on a laptop, I'm handling and pushing at the same time somewhere between 3,000 and 5,000 events per second, which just kind of gives you an idea of what this is capable of. And here it's actually closer to 6 right now. So does the Elastic Stack scale? Absolutely. Scales horizontally, quickly, and you can enrich the crap out of data as John has shown. So that's really my demo at this point. It's just a quick down and dirty, setting things up as quick as we can. Without the typos, this would have been less than 15 minutes, which is just freaking awesome. Some things I want to real quickly mention before we go into questions and answers. We do have a SIEM Summit coming up in November. This is a special 2-day summit that is all about using logs and SIEMs to tactically catch the bad guys. It's a no fluff. We're not focusing on managerial stuff. We're not focusing on compliance. It's literally how do we catch the bad guys? And I can tell you the answer is not traditional IDS with PCAPs. Windows logs, flow data, DNS logs, as John showed, there are much easier, high fidelity, low false positive methods to catch the bad guys. It's not security products. It's just proper detection, and this summit is going to focus in on that. The other thing, because we've been asked so much about standing up a tactical SIEM from 555, is there might be, and I don't know if I'm supposed to mention this or not, so don't shoot me and don't get me in trouble, but there might be a 2-day course that John and I are writing that is all about setting up your own free SIEM. Similar to what I just did in 15 minutes, but in much more detail on how to feed and care and tune and customize. So if you're interested in that, feel free to reach out or stay tuned to the future webcasts in the series. And at this point, I'm going to go ahead and open up for questions.
All right, well, thank you for that great presentation. We have some questions ready for the Q&A. However, if anyone has a question for our presenters, please enter it into the questions window now. First of all, Justin, would you mind pulling up the last slide? It looks like we're kind of looking at the thumbnails on the side. Thank you. Logstash's input module can process syslog and other things, but can it process Windows events?
Yes, absolutely. So for that, what you're probably going to do is send logs over an agent to either TCP or UDP, unless you're using WinLogBeat, in which case you'll use beats. So there's actually many different ways to handle Windows. I'd recommend either using WinLogBeat with the native beats of Logstash, or use an agent like NXLog and send it over TCP.
All right, thanks. Now that you've mentioned that 2-day, there's people who are very interested in that. And one person asks, how will the 2-day course differ from SEC 555?
That's a great question. So 555 is SIEM agnostic. It is completely neutral. I don't care what SIEM you're having. I just want to show you techniques that work. 555 is entirely focused on making your SIEMs tactical, weaponizing them so analysts can use them for what they were intended to do, and taking normal logs and showing you how to catch the bad guys. Similar to what John did with DNS, that was only a very small portion of some of the techniques we talk about in 555. It's an amazing class focused on tactical detection. The 2-day class that I'm hinting about, that you're going to get me in trouble for, but I totally appreciate it, is how to stand up an open source SIEM and use it. So it's more of a system administration. I want to stand up a tactical SIEM, but it's not focused on detection techniques. It's focused on building and setting up your own SIEM that you can support.
All right, thanks. Can you elaborate on the resource needs of a master eligible node versus a data node?
So master is just maintaining Elasticsearch cluster state. So even in a large environment, you're probably going to have 3 master nodes that are very small CPU and memory. You know, could even be anywhere between 4 and 16 gig of RAM a piece, and they don't store any data. They just make sure they health check and make sure that the data nodes are working properly. The data nodes, though, are going to be bigger and store all your data. So when you think of Elasticsearch, you're probably thinking of data nodes, and those you could have an unlimited amount of. So don't get caught up too much on the master nodes. Those are just coordinating nodes. They just make sure things go where they're supposed to and that everything is working as intended. So very small hardware footprint versus actual doing the work, which are the data nodes and storing data, and that's where all your hardware is going to be.
All right, thanks. If we want to set up a home lab for ELK Stack, what would be the recommended infra requirements? Can we do this with a few Raspberry PLs and use USB flash drives?
Let's say no to the Raspberry Pis, just because of the...
I wasn't reading that correctly, sorry. My eyes are going.
So your home, like if you have a home laptop with, say, 8 gig of RAM, you're going to be able to do this very easily. What I might recommend for you guys is Google search Security Onion Tech Preview, and you want this Tech Preview 3. This will actually walk you through how to set up a Security Onion all-in-one, and it'll actually have pre-built dashboards like some of this stuff. So if you're wanting to just goof off and play with it, it's a completely open source, not really intended to be ran in production, but in less than an hour or two, you could have a full-fledged elk stack stood up with alerting, some of the enrichment techniques we're talking about already built out. The other thing, because someone's probably going to ask, if you're wondering about Logstash configurations, first of all, I'm going to point you to the third part of this web series, because that's all on using Logstash parsing and enrichment techniques. Until then, though, there's also this GitHub page, which is also linked to in the presentation here. If you go to this link right here, sec555.com/demo, it'll actually link you to this GitHub anyway. This is a community-supported list of tons and tons of Logstash configuration files, with the goal that the community will gather together and just do awesome detection and awesome open source SIEM solutions. And that's something John and I are supporting and building for free for the community.
All right, thanks.
So leave that.
Curious on recommendations for log storage retention. I realize it's subjective, but I think they mean subjective, but the further out you get from the collection time, the less value they can provide. I'm not sure if that's really a question or a comment.
Yeah, so that's something that's an open-ended question, so it's hard to answer that one, and it does change. I can tell you one thing we talk about heavily in 555, and we'll also probably talk about in the 2-day, is retention requirements like compliance, PCI, government regulations. Sometimes we take those two black and white. There's actually filtering techniques we can do to shrink those down. Most detection techniques actually only require 24 hours worth of data. Like the domain technique that John showed earlier, that is almost near real time, and you don't need to keep those logs for a long time. So a good retention period could just be 3 days. That way you can see it over the weekend. More realistically, you're probably talking 7 to 30 days. And then compliance, you just got to keep it however long they say. But the question is more of what can you filter out of that, because compliance does not require you to log everything. And I know I'm putting myself on a limb there. Lawyers are getting on the phone, getting ready to scream at me, but I'm comfortable saying that.
All right, thanks. We have probably 12 to 15 more questions. I'm happy to continue. I don't know if people can stay beyond the hour. What are your thoughts?
I'm available. Throw them at me.
We'll just keep on rolling. What are the SecOps implications of using on-the-fly lookups of domain information in your SIEM configuration?
Awesome sauce is what it is. Yes, so technically if you do a whois lookup, that's about a half a second time hit. But if you're using the tool that John is referencing, which is Domain Stats, also linked to in my GitHub by Mark Baggett, it caches that in memory. So if you were to get 1,000 requests for the same domain, it's only going to do it once from a workload standpoint. So all the tools that we're sharing in this, or that are in 555, have been tested and work in production environments doing massive data analysis. So to sum up your question, they just work. And that entropy thing, that is near real time anyway. The overhead is very minimal.
All right, thanks. What is the best load balancing strategy for a large sysmon deployment using Logstash?
Load balancing with Sysmon, which is a Microsoft extension from sysinternals, that is probably going to be best done with WinLogbeat because it natively load balances to Logstash. Alternatively, you could do nxlog to any type of hardware load balancer, or you could use a free one like HAProxy. The answer to your question is more of if you're properly doing Sysmon filtering, which Sysmon can do itself, you'll be fine.
Do you have any sizing guidelines for Logstash, CPU, memory storage?
I have a generic rule of thumb. I typically size those at 64 gig of RAM and anywhere between 4 and 8 cores. A really rough estimate is to plan on roughly 600 to 1,000 EPS per core. That's for Logstash. Elastic is more on how much data you need for storage and just making sure you have enough SSD for speed. But say a 10-node Elasticsearch cluster, and by that I mean data, 64 gig of RAM a piece, and let's say 12 cores, that'll be able to get you close to 20,000 events per second, and it'll be able to handle that just fine. In Kibana, you just need one of because it's just a report instance. It doesn't actually do anything.
Is there a plan for certification for 555?
Oh, fantastic question. Yes. And actually, because 555 has been so successful already, it likely will have a GIAC exam the first half of next year, which is unheard of for new classes.
All right, thanks. Let's see. I have the same challenge that Justin had with Logstash. I can't get indexes into Elastic from Logstash. Where can we get the config commands? And somebody else says, how do you design your indices? One per date, one per log type? How many shards?
So we really got two questions here. If you're having trouble getting logs from Logstash to Elasticsearch, you had a typo, which is what I did. My recommendation is to start with like Security Onion Technology Preview 3, or even hit me up after the webcast and I'll help you out a little bit. Usually it's just a typo, or you're forgetting to add authentication if you've installed XPack, because as soon as you install XPack, it requires authentication in your config files. The second part of that is how are you doing your index names? And in truth for that varies by use case. I like to do things like, let's say I have 10 different firewall vendors. I'll roll those all up into an index called firewall, like Logstash firewall. And as long as I have a decent amount of logs, I will tend to roll them up to per day indexes. Most of the time I'll default to a per day index unless there's a very low volume of logs, in which I might do a per month or per year, or in very rare instances I'll just not specify a date at all and just always have one index. But most of the time you want to do a default of per day indexes. And for those of you who don't know what that is when logs come in, like let's say we're dealing with Windows logs, they would come into logstash-windows-2017-06-09, and then the next day it would increment the day. And the reason for that is it allows you to handle retention very well, or move between solid states and SATA after a certain period of time. And that's primarily where you're sizing that off of.
All right, thanks. This might be more of a comment. Log collection. What's a good strategy for data gathering? Collect everything. Sounds like a comment.
Don't collect everything. Don't collect everything. If you're going to collect everything, so when I do log collection, there's three ways of doing it. Input driven, which is collect everything. Output driven, which is to collect only the things you know you want. Or hybrid. And I recommend hybrid, which means you start out collecting everything, and then you regularly, such as once a week, once a month, go through and filter out the stuff you don't need. And if you do that, you'll end up filtering 90% plus of your logs, because there's a lot of stuff you just don't need.
All right, thanks. Have you tried, I think it's SIEM yet?
Yes, SIEM is another open source Elastic Stack implementation. They've done a great job. The main reason I'm not using it is I like my Logstash configuration files, like on that GitHub, go way more advanced and have way more enrichment. and I'm building those into Security Onion, which is one of the best open source platforms I've ever seen in my lifetime. I have 58 certifications, I've trained government, I've trained every industry known to man, and Security Onion is still my favorite free open source implementation. So I am partnering with them to bake all this Elastic stuff that John and I have configured into their platform. And they're going to have their own Elastic stack integrated with NSM and packet capture.
All right. Justin, momentarily, could you please go to the summit slide? I'm not sure if this one's an appropriate question or not, so let me know. This looks very similar to Graylog, which also uses Elasticsearch on back end. Can you summarize differences between Graylog and the solutions in this demo?
Graylog does use Elasticsearch on the back end. It is designed to be stood up extremely quickly and easy to maintain. It is a viable solution. What I found, though, is I cannot tune it as heavily as I can the default Elastic stack. So I tend to avoid Graylog entirely. If you just need to do log collection and want it to be as simple as possible, it is a fantastic suite. If you want to do tactical SIM with lots of enrichment and implement ways to catch the bad guys, I would steer you more towards the Elastic stack with some of the customizations that John and I are sharing in this webcast.
All right, thanks. How many components or hardware are involved to implement the SIM tool?
So if you're trying to implement these, there's effectively 3, Logstash, Kibana, and Elasticsearch. You technically could put those all in a single box if you're doing a proof of concept. So you could have a single hardware platform that has all of this on one box. When you start to go into production, that's when you're going to start scaling out, which you just scale out as needed. So I guess to answer your question, you could just do this on one box.
All right, thanks. Are the packages you installed available for other versions of Linux?
The packages that I installed for this demo were straight from the Elastic's website. So you would literally just go to their download page and download them. They work for CentOS, Red Hat, Ubuntu, pretty much any flavor of Linux.
Was the whole demo done on your laptop?
Yes. The whole demo was done on my laptop using VMware Workstation, and I opted to use multiple virtual machines rather than showing it on one because I feel it's more realistic to what you would do in a full-fledged production environment. And again, I have a laptop that is effectively less than $2,000 that is doing almost 6,000 events per second. That's just awesome.
All right. What about the possibilities to integrate intelligent feeds for correlation or enrichment? Are there APIs or apps extensions available, like with commercial tools such as Splunk?
So in regards to threat feeds, you could do commercial or open source ones in conjunction with the Elastic stack. For example, there's a project called CRITS. There's CIF, the Collective Intelligence Framework. There's the the Critical Stack. All of these are open source threat feeds. I'm going to make a comment, so please don't hurt me, but threat feeds are not near as helpful as they are advertised as, to the point where I actually caution organizations that letting your tier 1 analysts see threat feed information actually hurts them more than it helps them. And I know that's a very controversial thing to say, but the enrichment techniques or some of the purpose-built detects that John and I are pushing in 555, that's what SIMs were intended to do. The threat feeds are traditional blacklists with varying levels of accuracy, and I found that they end up generating too many false positives. So while you can integrate them, I'm going to question whether you're actually getting the value out of them that you think you are.
All right, thanks. What are the benefits of implementing a tactical SIM?
So the benefits of a tactical SIM is it's just purpose-built. Many of us have these SIMs that are bogged down with so much data that I call them the coffee break SIM. and that's where every time you search, you have to go get a coffee. Tactical SIEM is designed with the purpose of catching the bad guys. So it's the data is driving analysis rather than having so much data you don't know where to start. So it's quicker, it's faster, it's more agile. Correlations for a purpose, enrichment for a purpose. It's just the whole that you've designed it with the thought of catching the bad guys. Where your compliance SIEMs, they're kind of too far gone, and to fix them is very difficult. And that's where John was pointing out the slide about doing a dual stack SIEM. So go back to that. You're sending some data to a tactical SIEM, and then all data is your compliance SIEM. Compliance SIEM is slow but has everything. Your tactical SIEM is where you're doing hunt teaming and actual catching the bad guys.
Can you elaborate more on the XPack authentication from Logstash? It's quite a challenge and not so many solutions to it. And they also say, thanks for the webinar. It's been so informative.
Thank you. As far as XPack authentication, it's effectively role-based access controls. So you can set up users or groups, and then you can assign them to see certain data, even to the field level. So you can integrate with Active Directory, LDAP, Radius. Effectively, any form of authentication you need to do, XPack can allow it. It also enables encryption so that your passwords are not being sent in clear text. And then again, you've got to set it up to say, like maybe your DevOps team should be able to look at web server logs. Maybe your security team should be able to see everything. And XPack is going to allow you to do that from a security standpoint.
All right, how much EPS, excuse me, how much EPS usually a home LAN generates, assuming a few Windows, laptops, plus Wi-Fi router, cell phones, etc.?
So that's going to vary dramatically, and here's my explanation. How you've tuned your Windows systems or how your applications are set up wildly changes the amount of logs they're going to generate. And on top of that, it depends on what agent you're doing, because most agents are only going to pick up the default locations like application, system, and security. In my home lab, I crank logging up to the max because I'm doing security research, and I can generate on a, let's say, 20 Windows boxes, a FortiGate firewall, IDS system with Security Onion, wireless NAC, all this stuff. That's my lab is pretty crazy, and I'm probably doing somewhere between 20 and 50 gig of logs a day, which still could fit pretty easily on an external SATA hard drive. So it's still a great idea, but in productions, I'm going to push you guys strongly to start filtering stuff out, because you can filter 90% plus of your logs, and in your home environment, that also lets you have more data that you care about without needing so much hardware. So filter, filter, filter. That's one of the things I'm going to push for the day.
All right. Is it possible to set up alerts with Kibana on correlated logs?
With Kibana, no. If you're doing commercial XPack, there's Watcher, which you configure through Kibana. Watcher, in my opinion, is a little hard to work with. Usually what I push people towards is a tool called Elasticsearch. It's developed by Yelp. It's also in the slide deck earlier on. That you just create rule configuration files and you start the service. And that will generate alerts and put them in Kibana for you to see. You just have to write the alerts in configuration text files. So I'd recommend Elasticsearch for that. And that actually is more capable than many commercial AI engines.
Have you tried to work with ROC NSM or SELKS, SELKS, or have you tried them before?
Yes, I've tried both of them, and again, both completely viable. I just lean towards Security Onion as it's been around a long time. I personally know the author, Doug Burks. He's a Christian father, cares about the community more than a lot of people I know, and I directly am able to influence Security Onion, so I lean and steer people towards that instead of those. Those are just alternatives to Security Onion. Nothing wrong with them.
All right. Have you configured Logstash to be a forwarder, meaning accept all logs and send a copy to a database than a copy to the tactical SIEM. Is this something that you see happening in the market?
Yes, yes, and yes. Logstash is absolutely viable for collecting all logs and splitting them to multiple SIEMs. Some folks have used that to migrate off of their commercial SIEM. Some folks have used that to keep their commercial SIEM and have tactical and commercial.
Can I get alerts sent to my email or to my phone using Kibana?
That you can do with Elasticsearch, yes, but not Kibana.
Okay. Well, with that, we're pretty much out of questions and time. Thank you so much, Justin and John, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.